Okay, going to run through exit slip 4-3. Our I can statement here, we're supposed to try to generate expressions that follow patterns. Okay, and this can be pretty tough at times. You've got to kind of find the pattern and figure how to get it into an expression so that we can find answers for any step in the pattern that we get to. So in this case, I'm studying this pattern here. Looks like I've got a group of 2, then it goes to 4, and to 6, and then to 8. So you can look, it's kind of adding 2 every time. Some people could see, because you got 2, 4, 6. There's different ways to look at it, 2, 4, 6, 8. So you're adding 2. I can also see that, you know, you have a group of 2 every time, and then I'm taking it times 2. Like here I have 1 group of 2. Here I have 2 groups of 2. Here I have 3 groups of 2. Here I have 4 groups of 2. So that's the pattern that I'm seeing, that multiplicative pattern, that you're just a group of 2 more every time. So if you're looking at it multiplying on step 1, you're on that first step, you just have 1 group of 2 for 2 dots. This one I have 2 groups of 2. This one now I have 1, 2, 3 groups of 2. So on the 4 I'd have 4 groups of 2, which I do. So I found the pattern. I just have 4 groups of 2 here. So I know here I have 4, 6, and 8 dots. So what if I have 100? I don't want to draw out 100 steps. So I can see the pattern, whatever step I'm on, I'm taking it times 2. So if I'm on the 100th step, I'd do 100 times 2. I'd have 100 groups of 2 if I'm following this pattern, which I know without drawing the picture then, I'd get 200 dots. Okay, so what's the general pattern then? We're trying to come up with an expression for any step. Okay, so I can just call the step number n. And then I know if I take whatever step I'm on times 2, that will get me how many dots I would have. And in this case, I don't know, and I just have a general expression that I've written right here. Can't really fill it in unless I know what n is. And again, I could plug any of these in. If it's the 100th step, 100 times 2 is 200. If it's the 4th step, we know we have 8, and it shows up and matches. So I found the formula or the expression that shows this growing pattern. Sometimes finding formulas for growing patterns can be kind of tough. All right, and this is one part of algebra. I know sometimes your brain don't always see these patterns and things, so that can make it tough at times. So you got to be looking for patterns. All right, so make sure you've got this written down. Again, I'll pause it if you need to before we scroll up and look at another one and see if we can find the pattern. All right, so on the second one here, get it out of that light there a little better. Okay. All right, so we've got same things, but we've got a different pattern. Step 1, I've got 1. Step 2, it looks like it grows up to 4 dots. Oh, and I'm going to kind of write some things I see here. There's 4 dots here. It goes to 9, 16. So I'm trying to find what's going on. Some people see here that I added 3, then I added 5, then I added 7. So you can think some adding things. Sometimes we're trying to find more multiplicative things, though, in some of these patterns, too. Another thing I notice is these things all make squares. So here I just have 1 row of 1. Here I have 2 rows of 2, 3 rows of 3, 4 rows of 4. So I start to see mathematically, I know these are called square numbers. And like, for example, step 1, if I take 1 and square it, which just means 1 times 1, 1 times itself, those exponents. So there's 1. This, in step 2, I have 2 squared. So 2 to the 2nd power, which I know also means 2 times 2. Again, you can write both those in there if you want to. Really, all you would need is 2 squared, though, and that gives me 4. 3 squared is 3 rows of 3, which is 9. So I can just write 3 squared, which is 9. And here it looks like it's 4 rows of 4, or 4 squared. 4 squared is 16. We know that means 4 times 4. So I can continue that pattern. Like 5 would be 5 squared. Step 6 would be 6 squared. Well, if I want step 100, that would just be 100 squared. Because I found the pattern, I don't want to draw that out. Okay, 100 times 100 would be 10,000. And so I found there'd be 10,000 dots if I got to step 100 if I kept going here. And again, in reality, we can't draw those things. So that's why I use these patterns and try and find these formulas to help us So in this case, if it's whatever step it was, I just squared it. Step 3, we squared it. So if it's step n, which means it could be any step we want, okay, it'd be n squared, or n to the second power. So if it was step 50, I just plug a 50 in here, it'd be 50 to the second power, or 50 squared, and I'd be able to find that answer. Okay, so again, finding those patterns, again, takes a little bit of number sense there, and you got to study it and kind of see what's going on, and then see what mathematically you can do, and patterns can get pretty difficult with some of these. Okay, so here are just a couple of examples.